welcome guys. Alok Shrivastava once again, and this is my quarantine look, the new look. You can see it, and this is at home. Obviously, this is the best place which I think in my home is my balcony. I've got my plants around myself, and this is one small fountain that I had made. Right, not that good, but yeah, it's still working, and I like it, right? So a lot is happening during this quarantine days and the COVID-19 or the Corona days. So I hope you all are keeping safe distance between you and the like other processes. So make sure, guys, you are safe. You you respect the social distancing. So during this time, a lot happened with me also. It's been a long time I had created a video. So while doing some exercises in the park, I got a ligament injury in my knee here. So I was not able to move for a couple of days. It's painful. So during that time, I got this look. Do give me a feedback on how it is looking. So. I had been seeing a lot of trends these days, especially these lockdown days around the world. People are more shifting onto the online things, which is good. There is no doubt about that. People are learning new things. A couple of my students who are not from India, from US, so they are sharing me that because the jobs are not those like that much, and they're unfortunately they're also getting laid off, so they're learning new skills. So things like the containers, the kubernetes, the Ansible part, the automation is what they are focusing on. So, and I hope you all will be focusing on that the same also. I'm trying to give you a slightly more depth or insight about the containers. I've seen people, yeah, we know the containers, which is fine, guys. There is no problem in that. But it is also always going to give you an edge if you know deep inside all these technologies that you are surrounded with, right? So whether it's Linux or it's Ansible or Docker or Kubernetes, whatever you do, you should be getting the detailed knowledge of everything. Superficial knowledge is not going to work, trust me, guys. So what I am going to share you in the video which you are seeing now is the life cycle of the container, how the container starts, what are the pros and cons that you should be doing or taking care of while you are managing the containers. Couple of things like why it is that when you exit from the bash shell of the container stops. Why? That is one of the things that we are going to discuss. What is the life cycle of a container? How the container starts, how it works, how it uses the ephemeral storage, or we call it the non-persistent storage, how it uses it, and then why it is not at all recommended to use -rm option. Never. Why it is being told. People don't share this, but you should never use -rm option while you start the container. So the moment you exit, the container got exited, right? It got stopped or terminated. Why it is not recommended to use that. And then we will be seeing about, is there a way out of coming out of the container shell, the bash shell, without actually pausing the container. And we will also be discussing about the restart policy of the containers, which are very important. So these are the things we are going to discuss. So let's start, guys. Time to move from this green place and go to the green cursor, right?
Okay guys, so let's start it. As we had just discussed, we are going to learn about the container life cycle. So right, so Docker under the hood is what we are going to talk about. So major things you should remember is that a container is simply a running instance of a Docker image. I hope you all are already aware of this. So containers are fast and the lightweight. The reason behind why the containers are much faster than the virtual machine is that the virtual machine does hardware virtualization, whereas the container does operating system virtualization, and they use the same kernel and the same OS. Whereas in case of the VMs or the virtual machines, every VM has its own separate kernel and the boot processes and all that stuff. So that is not required in case of a container lifecycle. So containers will run. This is very important, guys. Containers are supposed to be running some application, right, or a process. So if any application is not running inside the container, if there is no process which is running inside the container, container will stop. That's the reason. I'll be coming on to this. So container is a running instance of an image. We know this. The basic difference which I had just discussed is that VM is a full blown VM, right? It includes the operating system, the kernel and everything, whereas the containers are not like that. So the easiest way to start the container is simple: docker container run command. So I'm going to start this container with this command which is right there on the screen. So let's do this. I'm going to start a container, and then we will be discussing why when we exit from the container, once we had got the bash shell, the container exit, right? So this is my machine. I've got a lot of images there. I'll be just using the CentOS image to run it. So I give a docker container run. It's not required to give the container word. You can also give the docker run, but I've got a habit of doing it. Interactive terminal, I need a terminal, and I use the image CentOS, which is available here, right here. Even if the image is not there, it's going to download it. So I'm not bothered about that. And then we are going to give the shell. I wanted the shell, so I give a bin bash. Right, so I am inside the container. See the prompt change, that is the container ID. So now what I want you to give is a very simple command, ps-ef. We all are coming from the Linux background, so we know what this command is. You can see there is a bash process running, but the important part that I want you to focus is the PID is 1. This is the only process which is running inside the container, right? Though you are also seeing a ps-ef output is there, but it is a short lived process because I had executed the command. The only long living process is the bash shell, right? And containers are supposed to run an application or a process. So the moment I exit from here and I give the command docker ps, you will see here there is no container. The container exited, right? Why? Because the process that was running here, you had discarded that process, you had exited from the shell. That is why the the container stopped. Another way of explaining you is this: I can run another container. This time instead of this, I simply give a sleep command, sleep 20, right? Say sleep 20. So what will happen, guys? For 20 minutes, sorry, for 20 seconds, not minutes. For 20 seconds, the container will be running automatically, right? The moment the sleep commands end, so the process that was running inside the container ends, so the container will exit, right? So I press enter here, and I can open another terminal and check it out. If I do it fast here, I give a docker ps. Sorry, sudo, I'll do a su. I think I lost the time. Not a problem, the password is wrong. I'll give it again. That's not a big deal. Docker ps, yep, it's gone. So, and if I got it. And if I give this also exited, right? So let me give it again to explain you. I give this the same command again, and I go here and I give the docker ps. This is running. See, this is running. It will be running or active for 20 seconds. The moment the 20 seconds is gone, you will find that the container will be gone from this output. It will be exited. right? 17 seconds, 19 seconds, gone. That's great. I'm getting the time from here, right? So now we have got Docker PS, no container is running, and I have got 3 containers which are in the exited state, right? So this is the reason why when you exit from the shell, the container exit, because the only process that was running inside the container stopped, right? Now, okay, we already know this, the difference between the virtualization, the VMs and the containers. The only thing which I want you to understand is this, that this line, VMs does hardware virtualization, whereas the container does OS virtualization. So that is why the containers start fast, because if you see here, they don't need to turn up the complete kernel and like the init RD file and init ramfs and boot it, everything is there. So they just need the application here. So all that thing is being isolated and being shared with all the containers. So remember this thing, VM, hardware virtualization, containers, OS virtualization, right? So that is why the containers start faster. Okay, now another thing which I wanted you to understand is that we can also come out of the container without exiting it. There is an option there, and I had already explained you why the container exit, when we exit from the shell, is the only process which is running inside it was the bash shell, and we terminated that. So it doesn't have any process. I'll give you an example and show you if there is any other process also running there, then the container won't exit. So let's do one thing. I again give the same command. Yep, I am inside the container. Now you can exit from the container without actually stopping it by pressing Ctrl PQ. I think I had, yeah. So if I go back to my, and I press here, I'll write here, I'm pressing Ctrl PQ, right? So I press Ctrl PQ, right? I'm right on the OS, but the container is still running. It is not stopped because I hadn't terminated the shell, right? Now if I go again inside the container, so the bash process is already running. I hadn't exited from that. So if I go back inside the container, I should be seeing 2 processes, right? So let me copy the ID. I copy this ID, right? You copy this and do a docker exec, you know that, docker exec, right? And you give the your ID of the container and bin bash. Now see the difference, guys. If I give a ps-ef, you will see 2 bash shells are running. Wow. This is the first one from where I had done the Control PQ, and this is the second shell which is allocated to me when I had given the exec command, right? So now the 2 processes are running successfully. That means what? So currently this one is the active one, right? PID of 14. So if I exit from the container now, only the PID 14 will be killed, right? There will be one PID which is still running, is the PID 1. So I do it, even now the container is not dead, it is still running, because one process is still running inside the container. So you should know these things, like small things, what happens. And now what should be the right way of stopping the container, and what should be the right way of removing the container or deleting the container. So stopping the container gracefully and deleting the container gracefully is again very important things. So what we will be doing, if I want to stop it, I have to give the command docker container stop. That is how you do it gracefully, guys. We are gentlemen, right? And copy this and paste it here, right? So if I give a docker ps none of the container is active, and I give a docker ps -a, these are all the containers which are stopped, but they are not removed. So the first you should always stop the container gracefully, and then you should remove the container gracefully. This is how you should be doing. So I should be removing it, all of them, one by one. Now another thing which is a great no, you should never be doing that, is you should never try to run the -rm while you start the container, because what happens, it's a signal kill of Linux. So if I do a docker container run -rm it, this is, I've seen a lot of people using it, and I use the CentOS and bin bash, right? So okay, sorry, what happened? Oh, this is not rum, this is run, right? I am inside the container. Some people find it, oh, it's good for me because the moment I do a exit, okay, let me see this container ID. So this container ID or the container name is, I give a docker ps here from the different terminal. It is loving, boy, wow, but this is the command is not loving actually, trust me. So the moment I do a exit here, some people find, hey, that is good because the container got removed automatically, right? Automatically. I don't have that loving container here. So actually you are not loving the container, you are hating the container. Why? Because this is signal kill, not signal term. The moment you give the -rm, this is the signal kill of Linux. So the container stops abruptly, and we know what is the why the signal 15 is not at all recommended under normal Linux administration to kill the processes. We know that. So please don't do this. -rm, though it is convenient, but that's not secure, guys. One important thing, the second thing that I wanted you to understand is the storage part. We know that containers are champions in managing or using the non-persistent storage, right? They cannot persist the data, though we can use the volumes, we know it. But the containers are good in handling the non-persistent data. So let us see what happens to the storage right from the birth, throughout the work, vacation, and then eventually when the container dies. What happens to the storage? Okay, so I will be running a container once again. I will remove this. I will not use the remove. This is not good. I am inside the container, right? I am inside the container. Now, I can create a file here. I go to the temp. Now see it, guys, carefully. I go to the temp and I create a file, hello.txt. This is a file using non-persistent storage, right? I do a control D, right? Now I'm not I'm pressing, say, control P, control Q, right? I'm not exiting it. So I press control P, control Q. Sorry, what is this? Control P, control Q. Yeah, I'm out. So if I give a docker ps, this is running. Nice Newman. Wow, I'm getting really interesting names of the containers because I'm not specifying it. Now, where this ephemeral storage goes, where the container is storing it, right? So if you give a docker ---- version of command, and oh, I can give a docker info also. Sorry. Yep. You need to see you need to see your storage driver overlay to, right? That is it. So I'll be going under var lib, under container you will find a folder with the name overlay. Go here, and this is the location where the containers keep their non-persistent storage. So what's the date today? It is 30th of June 1359, right? So this is the one which, so if I go here, let me check, go inside it, copy, I do a cd, paste it, I do a ll, I go to diff, and here is the temp, and guys, there is my file. Wow. So you should know where the container stores the your non-persistent files, the location. Now you know how to find the location. That's great. Now even if I stop the container, this is not going to die, this file is not going to die, I will be getting this file. So I'm stopping the container, right? I can stop the container. So let's try this. So, and I stop it. So I give a docker container stop, and I give this file name, sorry, the ID. So container is stopped, docker ps, none of my container is running, I give a ps hyphen a, it is being stopped. The container is stopped, but the file is still there. See guys, the file still persists, the file is still there. So remember one thing, even if you stop the container, the data is still there, even when we have skipped the shell, and even when we had explicitly stopped the container. Guys, the data will be there until you explicitly remove the container, the data is going to be there, right? So if I just come out of this, I copy this path, I copy this whole path, now I am explicitly terminating it, right? I'm terminating the container, I'm stopping the container. So the command is docker container stop, and what was nice Newman, right? Thank you, nice Newman. So this container is gone. Okay, it is stopped. So sorry, now I have to remove it. It was already stopped. Perfect. Nice Newman is gone. The guy was nice to us. Now if I try to go to the same directory, it's gone. Now the non-persistent data will be lost only when you explicitly terminate the or remove the container. Remember that thing. And you should also know where the non-persistent storage goes. Right. So the graceful way of stopping the container is first do the stop and do the remove. Do not use --rm, right? Don't use that. Another way is the self-healing containers. So let me come back to my slides. Right, we have learned about the PQ. I hope you liked it. And then this all we had learned, how to stop the container, delete the container, container life cycle. We had created a file sample.txt here, and we had stopped the container, and right, we had again attached it, and see the file was there. So only when you permanently explicitly delete, there will be no chance of losing your data. Now the second thing, as I had already discussed, you should never recommend it to use the -rm option while you are running the container. It's a signal kill, right? So never use this command to run a container, though it is good for the testing, but you might develop a habit of doing it, right? And it's not a good practice, so don't do that. Now the last thing that I am going to talk about you is the self-healing containers. So self-healing containers means the container has a restart policy. In case I exit from the container should restart automatically, because there is some application, right, running there. So the restart policies can be applied on a per container basis, or we can do it. So there are 3 restart policies: always, unless stopped, and failed. Always means simplest: whenever the container stopped, start it again. Whenever it stopped, start it again. Wow, that's great. Wonderful. Right. So So I will be starting a container with the restart policy, right? And then when I exit from the shell, you will see the container starts. It just refused to die. Okay, let's try this. So this is a small command that, or a small thing which I'm going to explain it to you. So let us do this. I go back here and I give the command here. I'll be running a container here. Let's see if I have got some docker ps. I don't have any container running. Now see here guys, docker container run. I hope I'll write run, not rum. -it hyphen name is never die. Let's call it never die, right? And the restart policy is always. This is what I want you to focus, right? The rest of the things are you are already aware of, CentOS and bin bash. Now I'm inside the container. Wow, wonderful. Nothing rocket science here. I got only a single PID which is running. If I go to the second shell terminal and give the command docker ps, this is running never die, right? So the normal behavior of the container was that the moment I do an exit, it stopped, but not this one. This is never die, right? So because of my restart policy never die, the moment the restart policy of always, sorry, the name is never die, right? So the moment I start this, it will start automatically. See here, under normal behavior it should stop. No, this is not. See, it has restarted. You can check it from the time. It has restarted again after, right, 3 seconds ago, the moment I had exited from it. So this container will never die, so, right? So in case you want a container to be running even if someone accidentally exits from the shell, you should give the restart policy as always. So this is what you should understand. So the only way to remove is that you should explicitly stop it and remove it. That's the only way you should be doing it. So these are the things that you should be focusing on. Obviously you can inspect the container, docker container inspect, you can get a lot of details about it. So let's do this. Docker container inspect and never die, that's the name, right? You get a lot of information about it. What's the IP address, what's the gateway, right? The networking, the image which you are using, the host name where it is running, any volumes and stuff like that. We are not controlling the CPU and the RAM right now, so this is not a good thing. So we'll be discussing it in the next videos whenever I'll be putting it. And then guys, we can stop it, right? Wonderful. So we have got a lot of containers running here. Docker ps-a, or you can give the command here. I'll give you one more command, that is, so I have to stop all these containers and I have to remove all these containers. Wow, this is going to be a pain. So there is a way I can stop them and remove them? Yeah, let me first stop it. So that never die is running, so I give a docker container stop never die. That's done. Now till now it was up. Now let's see what's the status. It's exited, right? So it can be very painful if you have got a lot of containers running and you wanted to remove them manually. It can be painful. Here's a small hack. You use the command docker ls-aq. You get the IDs of all this and then you pass it as a variable. Docker container remove and pass it as the variable. I hope you got it what I'm doing, right? -aq and give it forcefully. Wow, dangerous command, but it removed everything. All the containers are removed. Those are stopped or running in my machine. So this is the cleanup, that is I told you, but you have to be very careful while doing it in the production and actually should not be used in the production, right? So what we have learned why the containers are fast. We have learned the difference between the VMs and the containers. Again repeating, VM is hardware virtualization, containers are operating system virtualization. Remember these things. And the life cycle of the container, why the container exit when we exit from the shell, and we had understood about the non-persistent storage, the life cycle, and then we have also learned about the details. So that was all for this video. I'll be seeing you very soon, trust me. We will be meeting soon again. Thank you. Stay safe, guys. Bye bye. Take care. Godspeed.